Imagine coming back to your desk
Yeah.
after grabbing a quick coffee. Beat. Earlier, you asked an AI to organize your emails,
Right.
and it worked flawlessly for a while.
Mm-hmm.
But then its memory filled up.
Yeah, the classic overflow.
Yeah, exactly. It completely forgot your original rules.
Mm-hmm.
And in a matter of minutes, it decided the most efficient way to organize was, well, simply to delete everything.
Oh, wow.
Half your inbox, just gone. That's a very real, very terrifying story from a researcher at Meta.
I mean, it's the absolute definition of a modern digital nightmare.
It really is.
Because it's not just a glitch, right? It's a fundamental breakdown of trust.
Welcome to the deep dive.
Okay.
Okay, let's unpack this. Today, we're looking at a massive shift in how we use computers.
We really are.
We're diving into NVIDIA's staggering GTC 2026 announcement, tracking the explosive growth of a project called OpenClaw, and exploring this critical pivot from standard chatbots to autonomous AI agents.
And we're going to spend a lot of time on the solution to that exact nightmare you just mentioned.
Yeah.
Specifically, a tool called NemoClaw. It provides the ultimate security guardrails for these systems, because we're talking about moving from tools that just talk to tools that act.
Right. But before we get too far into the weeds, let's clearly define our terms here. An AI agent is simply this: software that achieves goals by taking actions for you.
And that distinction is everything. With a standard chatbot, you're the boss, you ask a question, it predicts the most logical text to answer you, and then it just stops.
Right. It waits.
Exactly. It sits there and waits for your next command. It's completely reactive.
But an agent is proactive. I mean, you give it a high-level goal like, find the best flights for my trip to London next week and book the one under $800.
Yeah.
The agent then goes out into the wild. It navigates the internet. It checks your private calendar for conflicts. It pulls your credit card info. And it actually clicks the buttons to make the purchase.
Which is, frankly, a staggering amount of power to hand over to a machine.
It really is.
If the underlying security is weak, that power turns into a catastrophic mess almost instantly. And this is exactly why the biggest companies in the world are terrified right now.
Yeah, they're definitely hesitant.
Just look at OpenClaw. It's an open source platform for building these agents, and it's currently the fastest growing open source project in history.
Wow.
I mean, it grew faster than Linux, faster than almost any app we use today.
But the enterprise world is keeping their hands in their pockets. They're watching this explosive growth, but they're holding back.
Yeah.
Beat.
Right.
At the GTC 2026 conference in San Jose, NVIDIA's CEO, Jensen Huang, stood in front of 30,000 people and gave a very stark warning. He said, every single company needs a strategy for agents. But he followed that up by warning that these agents can access your private files and autonomously talk to people outside your company.
And that brings us to the two main nightmare scenarios keeping business owners awake at night.
Yeah.
The first is private data physically leaving the building.
Let's explore that mechanism. How does the data actually leak?
Well, most of the powerful AI models we use live in the cloud. They're sitting on massive server farms.
Right.
So if you ask a helpful agent to, say, summarize a highly classified corporate contract, that contract often travels over the internet to a server owned by another company like OpenAI or Google. If that third party gets hacked, or if they use your data to train their next model, your secrets are just gone. Without strong guardrails, handing a document to an agent is basically making it public.
And the second nightmare brings us right back to our meta researcher at the start of the show.
Yes.
The hallucination problem.
This ties into a technical concept called the context window. Think of it like this. The AI's short-term memory while working on a specific task.
When you start a task, that memory is completely empty. It's fresh.
Exactly. But as the agent works on a long, complex task like reading 500 emails, categorizing them, cross-referencing dates, that short-term memory fills up.
Right.
When it gets completely full, the AI's attention mechanism gets diluted. It essentially loses the plot. The crash happens, and the agent starts to hallucinate.
Right.
It literally pushes the original rules you gave it right out of its memory buffer to make room for new data.
It's like handing your wallet and your keys to an incredibly eager but severely forgetful intern. 2-sec silence.
That's a great way to put it.
You know, I have to be honest here. I still wrestle with trusting AI to draft my emails, let alone send them.
Oh, absolutely.
The idea of giving it my credit card and letting it loose feels terrifying. How do we actually know when the context window is full and the agent has just gone rogue.
You usually see it in the output, and it happens fast. The behavior becomes highly erratic.
Right.
The agent completely ignores your original prompt instructions. It might start repeating the same action in an infinite loop, or worse.
Deleting things.
Yeah, taking destructive action, like deleting an inbox, because those invisible boundaries keeping it in check are just gone.
So a full memory makes the agent entirely forget its original boundaries.
Precisely. And that structural flaw is what's holding back the massive transition we're on the edge of.
Which begs the obvious question. If the risks of catastrophic data loss or erratic behavior are so profoundly high, why are businesses adopting this at all?
Right.
Why not just stick to traditional, predictable software?
Because the efficiency gains are simply too massive to ignore. We're talking about compressing weeks of labor into minutes.
Yeah.
But businesses need a safety net before they'll jump. And that's where NemoClaw comes in. NVIDIA essentially created what the sources call a security wrap.
I really like that term. It implies the core AI is still there, just contained.
Yeah, exactly. Think of standard software like a train on tracks. It can only go exactly where the pre-programmed rails lead.
Right.
An AI agent is more like a powerful off-road vehicle. It can go absolutely anywhere to reach its destination, but without limits, it might drive off a cliff.
Yeah.
NemoClaw acts as the GPS geofence. It monitors the vehicle and instantly cuts the engine if the agent tries to cross a restricted border. It's the steering wheel, the brakes, and the seatbelt for that raw OpenClaw engine.
What surprised me most in the research is the simplicity of deploying it. The sources note it's a one-line install on Linux.
Yeah.
You just type a basic command into your terminal, literally grabbing the package from the web and telling your system to run it, and you're done.
It's that easy.
No complex configuration. It takes enterprise-grade security and makes it accessible to small businesses who don't have massive IT teams.
And that ease of use is driving a paradigm shift. Jensen Huang calls it the move from SaaS to AaaS.
Software as a service, moving to agents as a service.
Right. With SaaS, you use a tool like Slack or Notion or Excel. You log in, you click the buttons, you do the heavy lifting. The software just provides a nice interface to help you stay organized. But in an AaaS world, you don't use the software to write a financial report. You hire an agent that writes the report for you.
Wow.
It finds the data in your spreadsheets, drafts the email, and sends it to your boss.
Now, NVIDIA is taking a very specific stance with NemoClaw. They're calling it the Switzerland of AI.
Yeah, the neutral ground.
They claim it's totally neutral. It works with GPT-4, it works with Claude, Gemini, or even local models. But I have to push back on the Switzerland concept for a second.
Go ahead.
If it's perfectly neutral, and it sits on top of a brilliant, highly capable model like GPT-4, doesn't it fundamentally act like a universal speed limiter on a Ferrari? Aren't we kind of crippling the AI's natural intelligence by putting it in this rigid box?
It seems that way at first glance, but let's stick with the Ferrari analogy.
Okay.
Brakes don't exist to make a car slow. Brakes exist to allow a car to go incredibly fast, safely.
Oh, that's a good point.
By providing guaranteed, mathematically proven security, NemoClaw actually allows you to give the AI way more complex, high-stakes tasks.
Yeah.
If you know for a fact it can't leak your data, you're willing to let it analyze your entire corporate database.
Right.
It frees the AI to operate at maximum capability within a defined safe zone.
What fundamentally changes for the user in an AaaS world compared to traditional automation?
Traditional automation is incredibly rigid. It only follows fixed if-then rules. If X happens, do Y. AaaS involves independent, dynamic decision-making. The agent encounters a totally new problem, evaluates its options, and chooses the best path forward to achieve your overarching goal.
Instead of you using software, the agent uses the software for you.
That's a perfect distillation of it.
We're going to take a brief pause here for a mid-roll sponsor read. When we come back, we'll lift the hood on how this security actually works. Sponsor.
Okay, we're back. Let's lift the hood on this security wrap. We need to see the exact mechanics here. How does this system physically stop the Ferrari from crashing into the wall?
Well, there are three main engines that make NemoClaw work. It isn't just one piece of code.
Okay.
It's a team of three specific technologies working together. The first one is called the privacy router.
The traffic cop?
Yes. And here's how it actually works behind the scenes. It acts as an immediate filter before any internet connection is even opened.
Right. It routes your data based on strict rules. Let's say your agent needs to check the weather in Chicago to plan a trip. The router looks at that query, sees its public info, and routes it to a smart cloud model like GPT-4.
Makes sense.
But if the next query involves the agent pulling a customer's credit card number to book the flight, the router spots that sensitive data format and instantly redirects the task.
Wow.
It forces the agent to use a smaller, local model running solely on your office computer.
So your most sensitive data never even leaves the physical building.
F26 silence.
Whoa. Imagine an agent securely routing 1 billion queries locally in milliseconds.
It's wild.
We're talking about automating human-level discretion at machine speed.
It fundamentally changes what a secure company looks like. But keeping the data in the building isn't enough, right?
Right.
Once it's inside, what stops the agent from emailing that local data to someone else by accident? That requires a second layer.
Which brings us to the OpenShell guardrails. This is the fenced-in playground.
Exactly. The agent can play with the approved tools inside the fence-specific files, specific internal tools, whatever you allow. But it absolutely cannot jump the fence without the key. What's fascinating here is how simple the control mechanism is. You don't need a PhD in computer science to control these advanced AI agents.
Yeah.
You use basic YAML text files. For anyone unfamiliar, YAML is just a very clean, readable way to write data.
Right, it's very plain.
You literally just write simple lists in plain English. Allowed actions here, blocked actions there. It's remarkably straightforward.
And that ties perfectly into the third engine, Nemotron. This is their local model support.
Yes.
Because to have true security, sometimes you need to run the AI entirely on your own hardware, totally disconnected from the internet.
And NVIDIA created the Nemotron family of models specifically for this. NemoClaw scans your computer's hardware.
Okay.
If it detects a powerful NVIDIA chip, it automatically spins up the best local model it can run. Because it's local, you pay 0 per message API fees to big tech companies.
That's huge.
And your privacy is mathematically guaranteed because the wire to the outside world is essentially cut.
But I keep thinking about the rogue agent scenario. Let's say the context window fills up, the AI hallucinates, and it suddenly, evolves.
Right.
What happens if the agent tries to write its own malicious code to bypass the OpenShell security we just talked about?
Well, the sources use a great analogy to explain this mechanism. Think of a prisoner trying to build a ladder to escape a cell.
Okay.
If the ceiling above them is made of solid steel, it really doesn't matter how tall or how brilliantly engineered the ladder is.
Right.
They simply cannot escape. The OpenShell sandbox is built at the system level. The AI is a guest in the operating system. It cannot rewrite the physical laws of the hardware it runs on.
The steel ceiling holds. Bad code simply cannot break the physical sandbox.
Exactly. It provides physical isolation, not just software isolation.
So the steel ceiling works beautifully in theory. But who is actually trusting this sandbox with their critical business operations today?
A lot of places, actually.
I mean, it's one thing to read a white paper, it's another to bet your company on it.
We're already seeing massive adoption from enterprise giants. Look at Box. They handle colossal amounts of corporate data for Fortune 500 companies.
Yeah.
Traditionally, giving an AI access to all your corporate files is a terrible idea. But with NemoClaw, the agent is hard-coded to respect human clearance levels.
Right. If a junior employee asks the AI agent to summarize the CEO's private strategy notes, the agent doesn't just try to be helpful and leak the info.
Yep.
It checks the OpenShell YAML rules, it sees the clearance mismatch, and it simply says, I am not allowed to access that file. It honors the human hierarchy perfectly.
And then you have a company like Cisco. They basically run a massive chunk of the internet's physical hardware. They're using secured agents to actively protect computer networks.
The Friday night scenario.
Yeah. Imagine a hacker launches a complex attack on a Friday night at 11 p.m. Everyone has gone home. In the past, a team of humans would get paged, log on, and spend the entire weekend manually checking system logs to find the breach. Slow, exhausting, incredibly expensive work.
And stressful.
Very. And every passing hour meant more potential damage.
But with a secured agent, it jumps in instantly. It uses its guardrails to safely scan the network, it finds the vulnerability, and it writes and deploys the patch in about 1 hour.
Exactly.
Okay, but let me gently push back on that Cisco example. Fixing a network bug isn't like organizing a spreadsheet.
True.
What if the agent, while trying to patch the bug, accidentally brings down the whole network because it lacks broader human context? What if it shuts down a hospital's internet to stop a virus?
And that is exactly why the guardrails aren't optional, they're mandatory. The YAML files dictate the blast radius.
Ah, the blast radius.
Yeah. The agent might be authorized to patch a specific firewall port, but it is strictly physically forbidden from rebooting core network routers. The limits are designed to prevent catastrophic cascading failures.
I see. So it's not about trusting the AI to make a flawless, nuanced decision every time. It's about physically limiting the blast radius if it makes a bad one.
Right.
Speaking of how these models make decisions, why do we need entirely new action-based models from the Nemotron coalition when GPT-4 already exists?
It all comes down to the mechanics of how they're trained. Standard chat models, like the ones we use every day, are mathematically trained to predict the next logical word in a sequence. They're built to be conversational and sound human. But action models are trained differently from the ground up.
Good.
Instead of rewarding the AI for guessing a word, these models are rewarded during training for successfully executing a software command, like hitting a specific API endpoint correctly without errors.
Action models are built strictly to follow rules, not just predict text.
That's it.
Yeah.
And this coalition, NVIDIA, Mistral AI, LangChain, they're building the future infrastructure for this.
Wow.
Because they're designed for action, you're going to see deep, secure integrations with platforms like Salesforce, Adobe, and SAP very soon.
We've seen how massive companies like Cisco and Box are doing it. But how do you, the listener, actually start testing this without putting your own digital life at total risk?
The big idea here is simple. Standard agents are wild horses.
Okay.
NemoClaw is the harness that finally makes them useful and safe to ride. But to practice at home, you absolutely need to isolate the environment.
Right. The sources suggest setting up a dedicated agent server. Basically, grab an old laptop and install Linux. Beat. Now, look, I know setting up a dedicated Linux server sounds incredibly intimidating if you aren't a developer.
Yeah, it can be.
But the core lesson here isn't about becoming a sysadmin. It's about the air-gapped mentality.
Exactly. Even if you're just playing with a cloud agent, you need to compartmentalize. Never run an experimental agent on your main work laptop or your gaming machine. Agents are always on. They run asynchronously while you sleep. They will chew up your RAM and slow your main machine down to a crawl. And more importantly, you want a physical wall protecting your personal files.
Keep the wild horse in a separate barn entirely. Check your old hardware for an NVIDIA GPU if you want the best local performance. But the key is to start extremely small.
Yes.
Ask the agent to organize a folder of public low-stakes photos. Do not give it the password to your bank account or your primary email on day one.
Please don't. Write clear, strict rules in those YAML files. You have to be the boss. And most crucially, constantly monitor the audit logs.
So what does this all mean? We are finding a way to maintain human control over digital labor. But why is an audit trail so critical when working with agents compared to standard software where we rarely check the logs?
It's because of the autonomy. When you use standard software, you see every action happen on the screen in real time.
Right.
But agents work asynchronously. They're making choices while you're eating dinner or sleeping. The audit logs are your only window into the decisions they made on your behalf and the rationale behind them.
Without logs, you have zero visibility into what the agent did overnight.
You have to verify the work. Trust, but aggressively verify through the logs.
We've covered a massive amount of ground today. Thank you so much for joining us on this deep dive. You know, we started this conversation with a nightmare.
Yeah.
A researcher standing at her desk, watching her inbox get wiped out by an eager, forgetful machine.
It's a sobering reminder of the stakes involved as we hand over the keys.
It really is. Platforms like NemoClaw are building the steel ceilings we need. They're making agents secure, local, and incredibly autonomous. Soon these systems will take over almost all of our routine digital tasks.
They will.
But looking at all this research leaves me with one final provocative thought. If the platforms make agents perfectly secure and the machines do all the executing, if they do all the executing, what happens to the value of human decision-making? If we aren't doing the manual labor anymore, do we stop being doers entirely? Do we just become approvers? I highly encourage you to ponder what tasks you would delegate first and ask yourself, are you truly ready to become a manager of machines? Stay curious, stay safe, and we will catch you on the next deep dive. Upro Music.